Hello everybody, welcome to Trans e-learning physics videos. Today we'll be discussing about Kirchhoff's law, and in that we'll be covering the practice problems related to Kirchhoff's law. So let's see what all questions we'll be covering in this video. The first question: calculate the equivalent resistance of the circuit shown. That means we have to find the total resistance across this circuit. Before proceeding further and telling you the steps to solve the question, I would like to discuss with you the two Kirchhoff's law that we would be using to solve this question. The rules are: first, the junction or current loop at any junction. First of all, what is a junction? You can see here that this is a junction, this one is a junction, and this one is a junction. Junction is a circuit point at which current divides. You can see here that the current is entering this junction and it is getting divided into three smaller currents, which I am labeling it as I1, I2, and I3. So this rule states that at any junction, the algebraic sum of currents entering the junction is equal to algebraic currents leaving it. So that means if this I current is entering this junction B, then the same amount of current should leave this circuit. That means I1 plus I2 plus I3 should be equal to I, because this law is in accordance with the law of conservation of electric charge. Now the second rule. The second is the loop or the voltage rule. For any closed loop, you can see a closed loop here, the algebraic sum of EMFs is equal to algebraic sum of current into resistance. We know that V is equals to IR. So when we are taking a closed loop, algebraic sum of their EMFs or the voltage across the circuit is equal to the algebraic sum of current into resistance, because in a circuit the current will be flowing through some resistance. So we have to consider the current into resistance for each one of them, and we have to take the sum of that, because this law is in accordance with law of conservation of energy. We have understood the two rules that we will be using in this question. Now the foremost step is to write the direction of the currents and see wherever the current is getting divided, because we'll be following this basic rule that when the current is same through some resistances, that means those resistances are in series. But if at some junction the current divides, that means those resistances are in parallel combination with each other. We can see here that this circuit has a 18 volt battery, and this is the positive terminal and this is the negative terminal. So the current will start flowing from the positive terminal of the battery, and let this current be I. Now, as I've told you, this is a junction, so the current will get divided. So here I am taking this one as I1. The current flowing through this is I2, and the current flowing through this, I am taking it as I3. Now if I see here, the current one is flowing through 50 ohm resistor. It will reach this point C, and from here the same I1 current will flow through the 250 ohm resistor, and it will reach the point D. So at D point we have I1. Now from here I2 is coming. This I2 current will flow through 200 ohm resistor, and this I2 will also reach at point D. So that means at this D junction we will be having the combination of I1 and I2. Now this I3 is flowing through this 300 ohm resistor, and this I3 will reach the circuit at E. We know, as per the junction rule, that the algebraic sum of the current entering the junction should be equal to the algebraic sum of the current leaving it. So if this I current is entering this junction, so it this I should flow out of that and it should reach the negative terminal of the battery. So we have to see here that whether we have done the segregation in the right manner or not. I is equals to I1 plus I2 plus I3 because we have divided this current into three smaller currents. So here at this D we have I1 and I2. So here if I draw the arrow I will write I1 and I2. So that means at this junction E, I1 and I2 are also approaching and I3 is also reaching. So at junction 3 there will be currents I1 plus I2 plus I3 and the sum of these is equals to I. So that means the I is entering the circuit at B and the current I is leaving the circuit from E. So whatever we have done the division of the current, that is appropriate. Now we have understood the division of the current in the circuit. Now it's time for us to analyze with the help of the currents that which all resistance are in series or which all resistance are in parallel so that we can do the calculations accordingly. Let's start the second step. As you can see here that from this junction B, current I is flowing through the circuit 15 ohm and the same current I1 is flowing through the circuit 215 ohm. As the current is same, that is I1 which is flowing through these two resistors, so that means these two resistors are in series. So we know that resistance in series are just added up. So we will be adding these to resistance. So I will give it as a name as resistance in series and 1. In this question, this is the first time we are finding the resistance in series. So resistance in series will be resistance across BC plus resistance across CD. So the value of this is 50 ohm and this is 250 ohm. So the resistance in series will be equals to 300 ohm. Now we have calculated the equivalent resistance of this resistance as well as this resistance. Now how the circuit will appear. You can see here the circuit will look like this, but for the sake of the simplicity I have made the circuit like this so that it's easy for us to solve the problem. Now you can see here that the current entered the circuit B and it got divided into three current, that is I3, I2 and I1. Now you can see that this current I1 is flowing through 300 ohm circuit, the I2 is flowing through 200 ohm circuit and I3 is flowing through 300 ohm circuit. As the current got divided, so that means these three resistors are in parallel. We will be applying this formula for parallel combination. So here I write 1 upon Rp1 will be equals to 1 upon Rs1, which we calculated, this one, plus 1 upon Rbd and 1 upon Rbe. So I'm just substituting the value here. This is 1 upon 300, this is 1 upon 200, this is 1 upon 300 again. So the value will come out to be Rp1 will be equal to 7 upon 600. Rp1 will come out to be 600 upon 7, taking the reciprocal. So Rp1 will come out to be 85.71 ohm. But on rounding off, we will get the value as 86 ohm. This equivalent resistance is of this whole circuit. Now after this, how the circle will look and what we're gonna do further, let's see. You can see here that the circuit which was here, it's gone now because now we have the equivalent resistance of those three resistors in parallel as 86 ohm. Now if we start from here, the current I will flow through this 100 ohm resistor. Now at this point B, there is no junction because no current is getting divided like it was earlier. So the same current will flow through this wire, and it will flow through 86 ohm resistor, and it will reach the point E, and from the point E the same current will flow through the 150 ohm, and it will reach the negative terminal of the battery. So that means as the current is same, so the final resistance will be equal to sum of resistance in parallel, what we calculated, that is 86 ohm, then a resistance across AB, and then resistance across EF. So this resistance final will come out to be 100 plus 86 plus 150 ohm. So on solving, this will come out to be 250 plus 86 ohm, that will be equal to 336 ohm. So this is the equivalent resistance of the circuit. So that was all about finding the resistance using the Kirchhoff law and the series and parallel combinations. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.